Hello everyone, I'm Darshan Padia. Today we are going to learn about input and output impedance of common emitter and common collector circuit. And as you can see in the screen, this is a common emitter circuit, and these are all the readings from the multimeters. This is input voltage, this is IB, this is IC, this is IE. These are output voltages and currents. As you can also notice here that IE almost equals to IC, and precisely IE equals IC plus IB, which you can verify. So first of all, what is impedance? Impedance is nothing but resistance, or rather a combination of reactance and resistance. So we can say it is a type of resistance. So we can find it through Ohm's law, V equals IR, where R equals V by I. But here instead of R, we can write Z as it is impedance. So Z equals V by I. But in this chapter, we will derive its formula. So let's derive it. This is common emitter circuit. The formula derivation is here. The output impedance includes the resistance and the impedance of base. So R1 parallel R2 parallel Z in base. Z in base is here, and the formula can be written by this. So as I told that R equals V by I, where Z equals V by I. Here V in, that is input voltage, is equal to IE RA dash, where RA dash is 25 millivolts upon IE. Now, why exactly 25 millivolts? You can see it here. 25 millivolt is the thermal voltage of junction at room temperature. So the junctions, yes. So let's move ahead. And the input current here, as you can see in the figure, that the input current is IB. So we write IB. Now we know that IE equals IC plus IB, but IB is negligible, so we can write IE equals almost equals IC. So here IC is written, and IC by IB equals beta. We know. So this Z in base equals beta times RA dash. So the whole impedance can be given like this. Similarly, for output impedance, uh, RC parallel to RL. RL is load resistance, and if load resistance is not present, then Z output equals RC only. And in a similar way, we can calculate the impedance for common collector, which is calculated here. Z in here, that is everything is almost same, but slight differences. Here R dash is also same. Z in equals R in R1 parallel R2 times beta times RE plus R dash E, because here input voltage is something different. And similarly, output impedance is calculated. Now, this page is for the summary of the upper page. Now, let us calculate the impedance for common emitter circuit. So, this circuit is common emitter circuit. All the values, the resistors and etc. are all the values are written in the page here. So all the values are written. We know IB and IC, and that's why we can calculate beta, that is IC upon IB. RE dash is also calculated here. Now let us calculate the input impedance. So by calculating the input impedance is 662.36 ohms, and the output impedance is 990 ohms. Uh, Also, let us observe the graph in the oscilloscope. Let us simulate it. Here you can see the green is output and the red is input. Here you can see there is a voltage gain 30 millivolts to 2.2 volts. So voltage gain can be seen here. Here you can check the divisions and observe the graph. Now let us move to CC, that is common collector. Uh, Similarly, here all the values are written from the multimeter. This is input voltage. This is input current. I mean IB. This is IC. This is IE. This is output voltage. Let us simulate it. Here, as you can observe, there is not much of a voltage gain. Let us go to oscilloscope, and yes, you can see it here. If I Yeah, I have written here too, so that you can see both input and output different. I mean separately. But if I write here 0, you will not see much difference. Yes, here green and red lines are overlapped, and there is no phase difference. Both are in phase. In CE, it was there was a phase difference. So yes, here you can see almost same. And so why do we use CC if there is no voltage gain? And so that will be answered by calculation. Let us calculate input and output impedances for CC. All the values are written, the beta is calculated, and the RE dash is also calculated. Here Z in is 3054 ohms and Z out is 43.39 ohms. And yes, here I have neglected RL as 1 upon 100,000 is negligible value. So as you can see here, the difference is high. Input voltage, input impedance is higher than output impedance. This condition is necessary for buffer circuits, and therefore the CE amplifier circuits are used as buffer circuits. Once again, we will simulate it and see. Yes, it is again live. So you can see here and observe the values. So here 30 millivolts VRMS. So here you will find the peak value. Thank you.